Hi everyone, myself Amlashmeena from RMD Engineering College, working as an assistant professor in ECE department. I welcome you all to the video lecture on electron devices and circuit theory. In this presentation, we are going to see about one of the special type of semiconductor devices that is nothing but tunnel diode, and we will also see about their energy band structure followed by VI characteristics. Very first, what is tunnel diode? We all know that if we increase the impurity concentration, the characteristics of p-n junction diode will completely change. This reason gives us one new type of diode, that is our tunnel diode. Here we can able to see the symbol of tunnel diode. Similar to p-n junction diode, here also we are having two terminals, one is anode and another one is cathode. Then this equation gives the relationship between barrier potential VB, impurity concentration Na, and width of the depletion layer W. From this equation we can understand that our barrier potential is directly proportional to width of the depletion layer, and depletion layer width is inversely proportional to impurity concentration. So if we increase the impurity concentration, depletion layer width will get reduced. Similar to that, barrier potential also will be reduced. Because of this condition, charge carriers will penetrate via the junction at the speed of the light. So this will produce large amount of forward current. This phenomenon is called as tunneling. That's why tunnel diodes are considered as highly doped p-n junction devices. Now we are going to see about energy band structure of tunnel diode. We all know that in p-n junction diode, the Fermi level will be nearer to the conduction band in N region and nearer to the valence band in P region. And we already know about these two expressions also. When it comes like tunnel diode, the Fermi level will be changed for each biasing conditions due to high impurity concentration. Now we will see about them one by one. This diagram shows the structure of energy band under open circuit condition. Here, Fermi level of P side and N side present at the same energy level. So, of course, there will be no flow of current in tunnel diode under this condition. Now we are going to give reverse bias to the tunnel diode. Whenever we give reverse bias, barrier potential will be increased when potential energy increases. So, in this diagram, we can clearly see that the conduction band as well as Fermi level in N side shift downwards with respect to P side. So filled states of P side will be at the same level of empty states of N side. So automatically electrons from P side will try to move into N side. This is clearly shown by the arrow mark in the diagram. This condition will increase the reverse diode current. Now we will see what will happen to the tunnel diode when we give the forward bias. This condition is totally opposite to our reverse bias condition. By the diagram shows, whenever forward bias is given, the N side energy levels shift upwards with respect to P side. So filled states of N side will be at the same level of empty states of P side. So there will be a current flow due to movement of electrons from N type to P type. Then if we keep on increasing the forward bias voltage at N side energy levels further rises, as we can see in this image. So there will be no empty states. This condition will reduce the tunnel current, almost it will reach to zero. Now take a look of this graph. This gives the relationship between voltage and current characteristics of tunnel diode. We all know that if we increase the forward voltage from 0, the current also increases. At one point, it reaches to its maximum value, which is called as peak current IP. That corresponding voltage, we will call them as peak voltage VP. Similar to this, when we increase the forward voltage beyond the peak voltage, the current decreases and it will reach its minimum value. That is known as valley current IV. That corresponding voltage is called as valley voltage VV. Here we are having two important parameters. Those are negative resistance and ratio of peak current to valley current. Then, what is negative resistance? It's a tunnel diode resistance which is offered when diode is operated in a negative resistance region. The formula is given here where Vf and If are nothing but forward voltage and forward current. Coming to the end, these are all some of the advantages of tunnel diode, and it can be used in switches, oscillators, mixture circuits, and also in amplifier. That's all about this presentation. I hope this video lecture will be helpful for you all. Thank you.